Hi, today we're going to be talking about kind of building up all the different things we've been talking over the last couple of weeks. The lockout, tagout, our meter safety, and now today we're dealing with arc flash and actual shock hazard. So we're talking about the things that could possibly kill you in this business, okay? And what that means. For us, we're going to kind of dumb down some of the numbers that have made it really, really hard. So this is for us. This is for our demonstration purposes only. We are not saying this applies to any of your other facilities, but our facility here, these are the requirements we use, so it makes it really simple for everybody to be able to do this. Okay, so basically a couple things we need right off the bat. We need a Cat 3 double insulated UL minimum listed meter. Okay, that's what we talked about last week. Now, double insulated meaning that you'll actually see the double square on there. That's what we really want to see. We want to see a clamp meter. We want to see something with good leads that we've tested, the thing actually works properly. And then we're going to use this three-step process for this guy. When it comes into what we want our boundaries, or we always use the 6-foot boundary. So anybody that is not a qualified person, remember, qualified, I don't care if they're licensed, whatever that, what we're worried about is, are they qualified to work on the environment they're in? Qualified meaning that they have demonstrated that they are qualified to work here. They've got training and they've demonstrated it, okay? I don't care if you're an electrician and you've done all these other things like this. We want to make sure you're qualified to work on the environment we're in today. So anybody that's not in that environment, this could be customers, this could be people like that. We want to be in that 6-foot hazard for the things we do. We do not work on anything above class 2 or type 2 arc fault situations. So basically, we're going to break this down real easy for you guys to do. There's a whole calculation that goes into making these. And you have to decide what is your arc flash hazard when working in these environments. So here we've got 0, 50 volts and below. We basically have nothing. This is still working on wearing your safety glasses, wearing your gloves, and wearing your hard hat. Then we get into our type 1 situation. This is where most of us are going to be all the time. This is up to 3-phase 120, 208, and 240. So this is 4 cal. You'll see on the equipment you'll have, like this particular one says 8.6. I want to double anything. This is my philosophy. Any environment I'm going to go into, I want to double the equipment I'm going to need. Okay? When we get into the 277 480 3-phase, that's a type 2 situation. Only qualified people for that, and we'll bring you up into the next level of what that means. That's a calculation of 8 cals. And again, you're going to see that on the clothing. This is a whole equation that's done this way. The way we're doing it is to make it really simple for you guys to do it. Hey, I'm at 240 and below 3-phase. This is a class 1 situation. I need clothing that is rated for the 4 cal situation. I'm working on 277 480. Boom, we move up to the next level. So most of all of our employees were working here at the very most because we do not work on live panels. We shut everything down. We tell the customer we're going to shut it down if we're going to be replacing breakers, doing testing, things like that. We're going to shut all that down. Okay, so certain situations that you are going to be out there where you can't shut it down. Maybe you're doing some testing. Maybe you're doing some ideas of where you're going to have to do. You've seen something that may not be appropriate. We're going to be racking breakers in and out. We have to minimize the situation as much as humanly possible for you not to get shocked or to have an arc flash. What causes arc flashes? Arc flashes are caused by usually transient currents. This could be from a motor turning off, could be a lightning strike near you. I've gone through 2 of these in my life. The worst one I ever had, we had a cross of both phases. It wasn't even my fault. It was a part that was installed improperly around me. When I got there, I pulled a meter. The meter can door, the actual cover itself wasn't installed properly. The bolts were missing. When I pulled the meter, it crossed over both phases and the whole room exploded. So definitely something that can happen by accident. We're dealing with something where, because of those transient currents, we could have 8 to 25,000 volts pumping through there. So we want to make sure our meters are rated for that. We want to make sure our test leads are rated for that. That's a really important one, that we haven't made our test leads defective, okay? Now, what are we wearing every other day? If we're near electrical stuff, we want to be wearing our gloves, our hearing protection that goes in our ears. So it's actually going to go in the ear canal. We do not want to wear the plastic ones on the side. We want to make sure we're wearing safety glasses. We want to make sure we're wearing our hard hat. We want to make sure we're wearing cotton clothing. We do not want anything that has nylon or synthetic fibers in there that could melt to our body. Now, when it comes to actually working on live electrical circuits, this is usually something only a couple people in your company are qualified to do, meaning that they have got the equipment and they've demonstrated that they can do that. So let's say we're working in an environment that doesn't have a main breaker. No way to turn off the power. Now we have to suit up, and everything we do has to be done with that. Now when we get into that class 1, we're dealing with a hard hat, a full face shield with a beard guard. We're dealing with the ability that this is not just a standard hard hat and a standard face shield. These are rated for that situation. This particular helmet is rated to a class 2. You can get bigger helmets, bigger full coverings as you get higher and higher up in those ratings. For what we do, class 2 is as high as I go. That's as much as I need. My suit is actually set up to handle a little bit more than that standard setup. And you want that. Go a little bit above. Don't try to brave it out. We have a suit that is not only rated for the fire side of this, but also the arc flash side of this. Fire rated clothing, it does not count. You need arc flash coating. We want to make sure we got full sleeves that come all the way down to our wrists, all the way up underneath our chin, and that we've used the goggle properly to protect us. Second of all, you're going to have a set of gloves. These gloves have a rubber insert that's been tested within the last year, and that is a leather glove on the outside to protect it, okay? Now when we get into this, we're going to go ahead, throw our gloves on. Now one thing I always do recommend is that you throw your hood on before you throw your gloves on, because it is kind of hard to put your hood on after the fact, okay? Now once we've got our gloves on, we're going to kind of go through the proper procedure. We come in here, we've turned off the power to this particular panel. This is in our training area, but we want to go ahead in a normal situation. We want to go ahead and turn it off. We want to take our tester here, make sure everything was dead inside the panel. So this would be a panel that would be completely dead. We've checked, and then we're going to go through the regular procedures. But I'm going to go ahead and do one that we can't test, or we can't shut all the way down, okay? So I'm going to come in here. I got my gloves on. I'm prepared. I know that I'm within that 6-foot range, so I've made sure everybody's away from me, or anybody that's affected is going to be away from me. Remember, the new 2020 code requires brand new breakers that are turned on and off is a class 1 situation. Those breakers can blow up, so we want to make sure whenever we're taking covers off and we have exposed power that we're dealing in those situations. So we're going to go ahead, make sure that your meters are able to do something like this. We want to have a proofing unit here. Can you see the screen there? Yeah. So we want to make sure you can see the screen. I'm just saying we can go ahead and... There we go. That might make it a little easier. Backlit screens are really nice. Again, we want a clamp meter. This particular meter is my commercial meter. It's rated all the way up to 1,000 volts, class 4, so it can work on the PG&E side. So we don't want to be testing on the side of the city side. So that's right in here we want to test. So I want to first, before I do anything else, pop down my shield here. I'm going to use my voltage pen. Check and make sure nothing's here. I'm going to go ahead and take my test leads. Now I'm going to take off my shield, and I'm not saying you can take off your shield at this point, just so you guys can hear me. So I've got my test leads. I made sure I haven't removed the caps. I only had the 4 millimeters that's exposed there, which is the bare minimum, and then I'm on the class A rating. Now this particular set allows me to roll up and down, and it actually tells me when I'm all the way down to the bottom that it's only class 2. So we want to make sure we're in that class A situation. We want to come over here. We've got our proofing unit. So we have the 3-step process. We're going to test at an outlet or something like that. or a proofing unit. I like using a proofing unit, it just makes it easier. I'm going to put my tips in here. It's going to tell me I have 236 volts. I can also test it in DC on these proofing units, which is really, really nice, testing both features. I'm going to go ahead and make sure when I'm testing the breakers, so let's say this whole thing was racked full of breakers. I'm going to go ahead and put my negative lead in first. I'm going to test both phases. So I can test both phases. I'm not getting anything there. Then I want to test across phases. See if I'm getting it there. Now this one that I can actually see the racking in the back here. I'm going to go ahead and actually tap inside the panel and make sure I'm able to get both phases. And then again, cross phases. This is something that will happen a lot. You will test phase to ground, phase to ground, phase to neutral, and you won't touch the cross, and you still can't figure out what's wrong with the breaker. They will lie to you. You must do all three measurements. Line to line, line to ground, line to ground, line to neutral if you're downstream, line to neutral, and then test across to make sure you're actually getting 240 volts to make sure there's not something wrong with the breaker. Now once we've done that, we've tested here, we can go ahead and we want to test the third step of this process, is come back and make sure the meter is still working properly. Okay? At that point, the meter is saying that it's working properly. I'm getting 236 volts on this particular meter. And now I'm able to, if at that situation, we can test to make sure everything's shut down properly. We can go ahead and take off our gloves and do the regular work of replacing the breaker, those kind of things. So I'm able to do this. And now when I go to fire the system back up again, after we're all said and done, remember this is we put a breaker in. And remember again, even with the hood on, you must be wearing safety glasses. These are a safety rated glasses here, and I must be wearing earplugs that goes in the actual ear canal. So once I've done that, I'm going to go ahead and pop my guy out here. I'm going to go ahead and remember, we are not testing on that side of that. Any testing that's done on the PG side is done with a voltage meter, with gloves, and with everything else. We're testing, this one happens to be dead because it's inside our shop here. Now once we put the cover back on, we always put covers back on before we turn anything back on. We'll go ahead and slide it in there, pop our cover back on. Always make sure when you're throwing your breakers in, they're in the off position. So make sure we put those in the off position. Same thing with main breakers. We want to make sure that we've shut down the city power if we're going to go ahead and do a main breaker there. Once I've done that, I'll go ahead and put my gloves back on, put my shield down, and if I'm in a situation where we're doing low breakers, I can go ahead, take my head. I usually use my offhand side. Now this is one of those ones debatable out there, but I'd rather have something if it was going to happen with my non-dominant hand versus my dominant hand. So I'm a big fan of going ahead, taking it, turning it away. Go ahead and fire it back on. Go ahead and fire our main breaker on down here. Once we've got that, then it's safe here. That's why the dead front is there. I'm going to ask the customer to go in and check for, to see if the power's come back on. I want them to go in and check. I want us not to have to go and recheck all this again to see if the power's come back on. I want the customer to do that. Once the customer's found out whether the power is back on, I also ask them to test at least one 220 circuit. Remember, you can have power on a lot of things inside the house, lighting, things like that, but not actually have 220, or 240, sorry. So I always have them test the dryer. I don't know why, but the dryer seems to be the one that's always causing the problem. So have them test their dryer, make sure the dryer kicks on, and then it actually gets hot inside there. So that'll be a really important one. Make sure it actually gets hot. So that's one of the ones I always have them check. Some things that I do recommend, make sure you got magnets on everything. Make sure your equipment's placed where you want it before you get started. Make sure everything you have is ready to go. I do like these hoods that are able to be popped down. Now the one difference you will have in the situation you just saw here, when I get up into the class 2 situation, is a full balaclava. That's the coating, you know, like your race car guys are going to have. It's going to cover their whole face, all the way down to their neck, tucked into their shirt, if you're going to go to that Class 2 rating above. So, Class 1, we don't need it, but making sure that all your equipment is rated for not only fire, but arc flash. So, if you guys have any questions, feel free to contact us. Again, this is for review purposes only. This is for the guys